run because of heat. You burn this fuel, it turns to a gas that's expanding really fast. You know, when gasoline burns, it explodes. And so we are able to take that heat and that expanding gas and drive a car, make a piston motor drive a car. But I'll tell you guys, those things are quite inefficient. Using all that gasoline to get things that hot and driving a car is, on a really good day, is somewhat less than 30% efficient. In other words, 2/3 of the energy goes to waste. And this wouldn't matter except we don't have an infinite amount of energy. We need to do more with less energy. So this is ice. Just to speed it up, I'm going to add a little water because then it gets, the heat gets, the cold gets spread out. It's good. You know, now that I've tried this, I don't think I can live without it. So this is another type of engine. It has a piston, and on the big round part is there's a piston inside, and then there's a smaller piston up here on top. And so this is just ice from the freezer, water ice, and if everything hasn't been damaged yet. It will run. Now you don't have to know that much about it, but you can tell that it's got to be a pretty efficient engine to run that fast on nothing but ice. So let me ask you guys. I talked about the thermos, the doer, keeps cold things cold and hot things hot. How does it know? Well, what is the source of energy that's making this engine run? It's heat. Just like in your car. Except the heat is coming from the room. It's the heat of the room heating the top black metal plate that's passing through the two pistons into the cold ice. So if we let it sit here long enough, the difference in temperature between the room and the ice will be too small and it will stop running. But for the next few minutes, I believe you'll be impressed at how efficient this is. And so this engine is called a Stirling engine, named after these two British guys named Stirling brothers, and they patented it in 1807. And Stirling engines used to be all over the place. They used to be on farms and in mines to pump water around. And the great thing is when the fuel ran out, which was usually coal, the pump would just stop. You didn't have to go turn anything off or on. It would just run out on its own. The hard part was it would stop when the fuel ran out, so you had to have enough fuel to keep it going as long as you wanted. Anyway, a Stirling engine is quite a bit more efficient than the engine in your car. Much more efficient. The trouble with them is they don't speed up and slow down very well. That's why everybody likes the engines in cars. You can accelerate or slow down very easily. But it seems to me we can do a lot better than that. So, for this next little thing, we need a volunteer. Guy in gray sweatshirt, very much. So, guy in gray sweatshirt, what's your name? Jesus? Jesus, come on up here if you would. Who made a mess? What an awful thing. This is madness. Jesus, do you have one of these? That's all right. No, yeah, that's what I do. So here's what you're going to do. If you would, Jesus. Turn the crank. It's easy, right, Jesus? Yes, no, it's very easy. That's what you're supposed to say. Except use your own voice. Say it into the microphone. Oh, it's very easy. Yes. All right, now. We will connect that to this light bulb. It gets a little harder, yes? He said yes. So I will now tighten another light bulb so there's two light bulbs. Oh, it's harder still, yes? Not so easy, is it, Mr. Jesus? Yeah. And now, now let's get it bright, dude. Come on, crank it down. The guy's working, you can hear him. All right, cool. So, these are old-style flashlight bulbs. In your house, you probably have a couple of these lying around. So you can hang on a second. This is a string of modern light-emitting diodes. And maybe you know the expression LED. So now, Jesus, give that a gentle turn. Okay, let's do this, Bill. Oh, that's right. Here, try it. Okay, Bill, that's really impressive. Okay. Wow, Bill, I'm sure glad you brought that. What the devil? This shouldn't do it. Go ahead. The word shut. So it's a lot easier, and it's a lot brighter, right? So when I was young, all we had was this style of light bulb. But nowadays, you guys, we have light-emitting diodes. These use about a tenth as much energy, and they're, well, it depends how you count, but they're about 10 times as bright, so in many applications, they're 100 times more efficient. And this is just the first, you doing okay? This is just the first idea. You guys may be alive when we can make the lights even more efficient. And if we do that, we'll be doing more with less, and we will, dare I say it, change the world. Now,